Welcome everybody to the visualization challenge. We are launching our second annual Visualize This challenge. So the data set is going to be available for downloading from midnight September 30th. And you will have 2 months to complete from, basically you can submit your visualization anytime from October 1st until midnight November 30th. And anybody can participate. So anybody who is associated with a Canadian university or Canadian research institution can participate. It could be either an individual or a team, and we will give out prizes. So obviously, if you submit a visualization as a team, we'll give out one prize per team, not one prize per team member. So the goal of the visualization challenge is basically to crowdsource the visualization of a real research complex three-dimensional multi-scale data set. So we're looking for good innovative ideas. So there are multiple variables in the data set. And the challenge is how to best show all these variables at the same time. So we also would like to draw your attention to visualization and to give you a chance to practice your knowledge of peer review and visit on a real research data set. So as I mentioned, you will have 2 months to compete. The data set is going to be available for downloading from midnight September 30th in a few days. And the link to the data set is going to be published on the Visualization Challenge webpage, the webpage that you can see right here in the shared window. So westgrid.ca/visualize_this_challenge. And I will also send an email with a link to the data set to all registered participants at midnight September 30th. So the rules are fairly simple. You can submit any solution that uses open source tools. So it could be peer review, could be visit, could be your own code in Python using VTK, let's say, or your own code in C++ using VTK or something else. So as long as this solution is open source and reproducible, doesn't use any commercial products, any commercial packages, you can submit it. And we're really looking for good ideas that anybody could reproduce. So we ask you that so by submitting your data set, you agree to for the solution to be published on our webpage. So we'll have a team of panel of judges, who will look at all submissions, and they will select the 3 or maybe 4 best submissions. We'll give out prizes, and these submissions, the workflows, the scripts, are going to be published on the Westgrid and Compute Canada pages. So the idea of the challenge is basically to crowdsource innovative ideas, visualization ideas, and then let everybody in Canadian research universities have access to these ideas in these workflows. So the prizes, I'll already mention the prizes. The top prize is actually really nice. It's going to be a 42 or 43 inch, can't remember, 4K monitor from Dell. So it's actually a professional level desktop monitor that is about $2,000 Canadian. So Dell EMC was kind enough to provide this just prize. And the second, third prizes are going to be a few SSD drives and also a partially subsidized trip to one of the Westgrid summer schools. So we're going to have at least 2 summer schools next year, in June next year. We have not decided yet on locations, but one of them is going to be in Vancouver. One is going to be east of the Rocky Mountains. So I'm going to walk now through the data set. As I mentioned, the data set is going to be available for downloading in a few days at the end of the month. And let me switch to the to my terminal. So the data set is actually comprised of 11 files. All of these are VTK files. So the original data set was in TechPlot format, but we converted it to VTK simply because VTK is much more common to be read and understood by pretty much any modern three-dimensional visualization package. So the main file is 419 megabytes large, and it's the three-dimensional data set describing airflow around counter-rotating wind turbines. So it's basically, this main file is a set of 5 variables. It's a single time step, so there's no time dependency. Single time step, 5 variables. So the variables are pressure, vorticity, and 3 components of the velocity. And it's airflow around turbine blades. And then the next 10 files, these ones, the ones I'm highlighting right here, are the polygonal meshes containing the same 5 variables, pressure, vorticity, and 3 components of velocity, on the surfaces of the turbine blades. So there are 10 blades in total, and 11 data files in total. So these are standard VTK files, and this is the first one, the three-dimensional data set is a VTK, unstructured grid VTK file. So these are three-dimensional, basically tetrahedra containing the 5 variables, and the surface files, these files for the blades are polygonal meshes containing the same five variables. So these can be read quite easily in Purview, in Visit, or if you use VTK library for Python or C++. So I'm going to, actually on the web page right here, I have a link how to read the data and sample visualizations. And I have a couple of scripts. Actually, one of them is a Purview state file. The other one is a Visit script. So I'm going to run this now and just will demonstrate you how to load and visualize, do some simple visualizations in real time. So the first file that you can actually download yourself is linked right here, bladeswithlines.pvsm. So it's a Purview state file, and you can load it if you start regular Purview desktop package on your laptop, and then go to File in the Purview menu and load state file. So navigate to the location of this state file. It will ask you to confirm the location of the data files. So data files are not yet available, so you won't be able to do this now, but in a few days you'll be able to run this exercise. And then you just load the state file, and it will load the data files, and basically we'll do the visualization. So let me do this now. So what I'm going to do is I'm going to just start Purview from the command line, and I'll say Purview and supply the state file from the command line. And now it's loading the data. So because the data set is several hundred megabytes long, it's going to take some time, maybe 10 to 20 seconds to load it, and then allow for some time to render. So the rendering is very simple. You see the individual turbine blades, and then you see the three-dimensional airflow. So it's already showing on my screen. Hopefully it's going to refresh inside the video window. So let's give it a couple of seconds. Right here. So hopefully you can see it on your screen. And what you see here is the airflow around the turbine blades. So the blades are colored by pressure, and that's what the color legend here is. So the value of pressure. Pressure is relative to the standard atmospheric pressure, so it can be both positive and negative. And the airflow is drawn with streamlines here. So you can take a look at the actual visualization pipeline right here. So let me just make this panel slightly, this window slightly bigger. So I first load the 10 polygonal files for the blades. Then I load the three-dimensional file for the airflow itself. Then I use the calculated filter to construct the three-dimensional velocity vector from the three velocity components. And then I bring up the stream tracer filter to draw the streamlines. And then I make them thicker with the tube filter. So that's all to it, fairly simple. And once you have the data set in a few days, you'll be able to just load the state file and do this visualization Purview yourself. So as you can see, this is a three-dimensional picture, very easy to visualize. So the challenge is really to visualize both the large-scale flow around the wind turbines and the small-scale turbulence around the blades. And this is somewhat challenging, especially that you have more than one variable. So I have 5 variables, as I mentioned. So the question is how to do this in the best way possible. So I could suggest several things. You could, for example, make a movie in Purview where you fly through the data set, or maybe you spin the data set, well, the object, the visualization in 3D around the vertical axis. And you can also at the same time turn on and off various views, various variables. So it will be nice to show, let's say, vorticity and pressure at the same time with the three-dimensional velocity, for example, using streamlines or something else. It's completely up to you how you do this. So this is a Purview. I'm going to show you. So as you can see, this is really a three-dimensional live picture. So it's fully interactive on my laptop. I see there's a lag in the video client, so it's not refreshed yet when I spin it. So there's a 10 to 15 second lag in the video client, but it works. As you can see, I can actually spin it around. The rotation is instantaneous in my Purview on my laptop, but it just takes some time for it to refresh inside the video client. Okay. So I'm going to close preview now, and I'm going to start visit, and we'll do a visualization with visit. So for visit, I have a visit Python script that is also downloadable right here. So it's called positive negative pressure.py. And it basically draws two isosurfaces. One is of positive pressure. The other one is of negative pressure around the turbine blades and the blades themselves. So it will draw a picture like this one. So let me just do this live. I'm going to start visit. Okay, so visit has started. And what I'm going to do next, so there are actually many different ways you can run a Python script inside visit. So what I'm going to do, I'm going to go to controls, and you can launch, so you can run Python scripts from launch command line interface menu, or you can do it from the command menu. So I'm going to open the command window, into which I'm going to paste the Python code. So actually, let me load it first into my text editor on the other screen. So here I have my Python code. I'm just going to paste it into this command window. So here we go. And I'm going to press the execute button. And then it will do the rendering. So it will load the datasets. And again, because the dataset is fairly large, it's going to take maybe 10 or 20 seconds to load it. And inside visit, you can actually see how the dataset is being loaded. So it's loading the turbine blades, the polygonal files for the blades with all 5 variables. And then it's going to load the three-dimensional airflow. Okay, so now it loaded the three-dimensional airflow, and now it's doing rendering. So you can see it's almost done. Okay, so it did rendering, and now it's adjusting. So okay, so it's all done. It adjusted the camera view, the zoom level, and so on. So this is the picture I see on my laptop, and this is done in Visit. So once again, you have the full Python Visit Python script that shows you how to load the polygonal meshes for the turbine blades and how to load the three-dimensional airflow. And what you do with this data is completely up to you. So this is a very simple visualization where I just draw constant surfaces of, well, surfaces of constant pressure. So 2 different values of pressure. And you can clearly see the three-dimensional turbulence around the turbine blades. So one thing you can do is, for example, add the streamlines here and perhaps zoom in and zoom out, make a movie, maybe spin around, turn on and off different variables and so on. So completely up to you what you do. So as I mentioned, there is no time dependency. It's a static data set, single time snapshot, but you can still make a movie. So you can make quite a lot of interesting animation types. So. As I mentioned, you are free to use any open source tools. So I just showed you Preview and Visit, how to load data and how to do simple visualizations. But in principle, you can use any other three-dimensional tool. So you could use MyVI, you could use something else, as long as it's open source and as long as you provide us the code or your script or your workflow, and we can reproduce it. This is a valid entry. So I think I'm gonna pause now. This is all I have. So thanks, everybody.